This video will cover in Class 3, which is day 1 of Standard 1. We're going to be introducing two topics today called segment addition and then also the idea of a midpoint. Before we do that though, we're going to spend a quick few minutes here reviewing what you should know from our vocabulary and notation unit. So your goal is to look at these four figures, A, B, C, D, and identify what you see. For each of these images, there are two things to do. Give a correct name for the figure, so that's using specifics like the letters that are involved on those figures, and then also match the figure with the correct vocabulary word from this vocabulary word bank off to the side. It would be a good idea to go ahead and pause this video so that you can give those four problems your best shot, and then when you resume the video, you'll see answers so that you can check your work. All right, welcome back. We are looking in this first diagram at a geometric figure that continues forever in both directions thanks to those arrows. So you should have selected the vocabulary word of line. If you look at figure B, it does not continue in both directions, so that would be a line segment. Whereas figure C doesn't have a piece of a line or a line segment at all, it's just this dot that represents a point in space, a location in space. We call that a point. And then finally, for figure D, we've got a geometric figure that starts at a particular location, point C here, and then continues on forever in only one direction through point D. That's what we call a ray. If we come back through and we give these figures names, to name lines, line segments, and rays, we always need two letters. The order of the letters doesn't matter for lines or line segments. You just need 2 points that are on the line or the line segment, and then you need the correct notation above those two letters. So for a line, it can be any 2 points on the line, and then the line symbol above those two letters. For a line segment, it can't be any 2 points. It has to be the end points. Those are the only ones available in this diagram, but if there was a third point available like C, we would ignore that one, and we would just focus on using the A and the B to show where that line segment starts and stops. And then it would get a line segment bar, but no arrows above those letters. You could also talk about B and A in that order. The line segment starts at B and ends at A. For points, you can include the word point with the capital letter, or you can just use the capital letter by itself. And then for a ray, the order of the letters is important. We must talk about where that ray begins first, so point C, and then a point that it passes through. That would be D. And then the ray symbol only has an arrow on the right side to show that it continues on forever through D. If this ray had another point on it, let's say point E, we could also name it ray CE. It starts at C, that's the end point, and then it passes through E and continues on forever in that direction. Okay, hopefully that review from vocabulary and notation over the past few days went well for you. So now we're headed on to the new material for Standard 1. So the first idea we're going to look at is called segment addition. And we're going to test your instincts to see if your instincts are good. So first things first, we've got two letters here, H and J. Normally we would expect those two letters to have some kind of a symbol above them, maybe a line symbol or a segment symbol or a ray symbol. If we take a peek at the diagram, between H and J would be a segment, but when that segment bar disappears, it symbolizes something different. This symbolizes the length of segment HJ. So it's a shorthand way, if we just put the two letters without a bar above it, to describe the length of that segment. So what they're asking us to think about is how far, or what the distance is, between point H and point J along that segment. What do you think it is? If it's 7 centimeters from point H to point K, and then 15 more centimeters from point K to point J, Hopefully your brain is telling you maybe to add those two distances together to get the total length between those 2 points. So 7 centimeters plus 15 centimeters would be 22 centimeters total. And that's the idea of segment addition. Part B is similar, but if we look at the information we're being given, not all of it is actually on the diagram. They're telling us here the length of HJ actually is 33 inches. I don't see a 33 down here anywhere. So it would be a good idea anytime you have information that's not on the picture to label it for yourself. So all the way from H to J is 33 inches. And this time the goal is to figure out the length of segment KJ. That's where these question marks are filled in here. What do you think we should do this time? If your thoughts were to take that total and to remove or to get rid of HK with subtraction to fill in what that leftover piece would be equal to, that was a good idea. You should end up with KJ being equal to 16 inches if you do that subtraction correctly. And then last but not least, we've got a different clue in part C here. They're telling us that K is in the middle of segment HJ. So the middle doesn't just mean anywhere randomly along the segment like we have in these two other examples. Could be closer to H, could be closer to K. The middle means the middle. So it means that from K to H and from K to J have to be identical. So when they ask us up here for the length of segment KJ, we can use that abbreviation to talk about the length of KJ. Just don't include the bar above those letters. That's going to be exactly the same, since this is the middle point, as the distance between H and K. So 5 centimeters. Okay, we're going to formalize some vocabulary here. The idea of segment addition is something called a postulate. In geometry, the idea of a postulate is something that we can't necessarily prove is true, but it makes sense. And so we use it as an idea to help us solve problems. Whereas a definition, which is what we're going to learn about when it comes to midpoints, is an official explanation of what that word means. So when we look at segment addition postulate, this is going to be a reason that we can give for work that we're going to do to solve for different segment lengths. Same thing with definition of midpoint. That's another reason that we can use to explain our work. The segment addition postulate talks about how we can take parts of a segment, and those parts of a segment can be added together. And when that happens, so think about this, HK added together with KJ, what that's going to do is it's going to equal to the length of a larger whole segment. So if we're looking back at example A, we can write out what's called a general equation by naming those parts that were added together using the letters in the diagram. So we have the length of HK, the length of segment HK. We added that to the length of segment KJ, and then that was equal to this entire length of segment HJ. So a general equation doesn't typically have the specific measurements. It just has the names for the lengths that are involved. Then to solve, we can substitute in the values that they give us. So HK up here is equal to 7 centimeters. KJ in the diagram was equal to 15 centimeters, and we did not know HJ at the beginning, so there wouldn't be anything to substitute there. 7 plus 15 then is equal to 22, and that gives us our answer for HJ. So in geometry, it's not just about getting the answer, but it's also about justifying your answer with both work and sometimes these general equations, and also sometimes with reasons. The reason related to this idea would have been segment addition postulate. Part B is very similar. We can use the same general equation when we're looking at part B up here. We still have HK added to the length of segment KJ, and that's equal to the length of the entire segment, HJ. But this time when we substitute our values in, HK is given to us as 17. We don't know KJ, so we can leave that. But HJ, that whole distance, was given to us. Now when we did this problem the first time, I did it with subtraction, 33 minus 17. That's exactly what this algebra equation would result in. Subtract 17 from both sides to isolate that KJ and land on your answer of 16. All right, continuing on, we're looking at definition of midpoint next. So a midpoint is going to be a point on a line segment. Sometimes we just call those segments, by the way, so if you leave out the word line, it's okay. That point, though, specifically divides the segment into two equal parts. So it's not just a random location, it's actually the halfway point of the line segment. And believe it or not, we use that idea up here when we were looking at example C. When K was in the middle of HJ, that really tells us that K is one of these midpoints. And so what we were able to do is we were able to say that HK was equal to the same as KJ. So our general equation wouldn't have addition in it this time, it would just be equals. We substitute in 5 for HK because that's what it's equal to, and then that tells us what KJ is equal to. KJ was equal to 5 centimeters, since those were the units used. Now, this equation can show up in a couple of different ways, using the idea of the halfway point as well, but we'll see that on day 2 when we do more work with segment addition postulate and midpoints. If the ideas that we've talked about so far have made sense to you and you're interested in earning blended release, go ahead and flip to the back side of this page and we're going to do some work with examples. If you feel like it would be better for you to go through the examples in class tomorrow, you can go ahead and stop the recording and we'll see you then. All right, for those who feel like this idea makes sense and you'd like to earn some blended release, we're going to go through these examples, but you are going to solve them and enter your answers in so that we can check to make sure you are understanding. So for example 1, go ahead and read through the information. My suggestion would be to label it on the diagram where it belongs. So the length of segment EF is x plus 3. The length of segment FG is 11, and the length of segment EG is 3x plus 2. Your goal is to find x. Go ahead and try to do that problem. Set up your general equation, your reason, use this space down here to solve the problem, and then check your answer. This is going to be a segment addition postulate problem because there's no mention of a midpoint. So the general equation would look like EF, the first part of the segment, plus FG, the second part of the segment, is equal to that entire segment. The reason for that would be segment addition postulate. Like we mentioned, there's no evidence of a midpoint, and so segment addition postulate will be our go-to. We're adding two small parts of the segment together to equal the whole thing. If we substitute in the specifics, EF is x plus 3. We're going to add to that FG 11, and then that will equal EG 3x plus 2. If you've made it this far, then that means that you probably know how to do this algebra, but I'm going to combine these like terms. I'm going to subtract x from both sides so that all the x's are on the same side of the equation. Subtract the 2 to accomplish the same thing for the numbers, and then last but not least, divide both sides by 2. So you should end up with x equal to 6. Move on to example 2, you can do the same thing. Label your picture first with the information, and then see if you can put together a general equation, a reason, an equation to solve specifically, and then an answer. LM is 2x minus 2, so that's this portion of the segment. MN is 3x minus 16, and this time they've told us that M is the midpoint of segment LN. We can mark that with something called congruent tick marks. Those little marks there show us in geometry terms that those two segments are equal. So that's what your general equation should have looked like. LM equals MN, thanks to, this time, the definition of midpoint. They told us there was a midpoint available, so we're using our understanding of what that word means to set up our equation. So 2x minus 2 gets substituted for LM. 3x minus 16 gets substituted for MN. Same thing as before, I'm going to move my variables to be on the same side of the equation. Be careful that negative 2 is left on that side. And then last but not least, add 16 to both sides, and this time x equals 14. If those examples have gone well so far, go ahead and move on to number 3. See what you can do with that one. Read carefully. Ooh, wait a minute. Come back up here. Number 2 asks us to do something more specific. We are supposed to be finding ln. So if x is equal to 14, we're not quite there. ln is this entire distance. So this is going to require us to take our x answer and use it to come up with some distances. 2 times 14 would be 28, minus 2 is 26. If we do the same calculation here, we should also get 26 because those should be equal. So then ln, that entire distance, would be equal to 52. On to number 3. Let's be careful about that from the start. We're supposed to be finding kj. So we're going to have to do the same thing at the end of this problem where we take our x and we plug it back in. This problem also has this little symbol next to it, which means this is a problem where you're going to look back and use some of your more difficult algebra skills from last year to also prepare you for algebra next year. So kind of looking back but also looking forward at the same time. All right, this time hj is given to us first, 5x plus 20. hk is x squared minus 14. That's where the more difficult algebra comes in. And then kj is 2x plus 6. No mention of a midpoint, so we're going to be dealing with segment addition postulate, again, for this problem. And that means we're going to be taking the two parts of this segment, hk and kj, adding those two together to give us the distance all the way from endpoint to endpoint, which in this case is hj. If you substitute into that equation, x squared minus 14 plus 2x plus 6 is going to be equal to 5x plus 20. And this is a more difficult equation to solve because of the x squareds and the x's. Combining together some like terms on this side, the negative 14 and the positive 6 become negative 8. And then anytime an equation has both x squared and x, we need to make it equal to 0 in order to solve. Subtracting 5x from both sides and subtracting 20 will take care of that. So we're going to be left with x squared minus 3x minus 28 is all equal to 0. Now there are lots of ways to solve these problems, but the process you're going to use is called factoring. Depending on who your Algebra 1 teacher is, you might have learned to factor in different ways, but this factoring problem is going to split up into the two factors x minus 7 and x plus 4. If we need to review that, that's one of the things we can take care of during class time. Once you get it factored, you'll split it into two parts where both of those parts can be equal to 0. And then x could be 7 or x could be negative 4. both are valuable algebra answers, but not necessarily geometry answers. So if we take 7 and we plug it back in for kj specifically, we would be doing 2 times 7 plus 6. So that would end up being 20. If we plugged it back in over here, it would be 7 squared minus 14. So 49 minus 14. Still a positive length for the segment, so that seems fine. If we plugged it in here, 5 times 7 would be 35 plus 20, positive length for the segment. So everything seems fine with x equals 7, which means 20 is an acceptable answer for kj. If, however, we take this negative 4 and we plug it in, 2 times negative 4 plus 6 is negative 2. A segment cannot have a negative length, so that means that this is what we call an extraneous solution. It does not work in geometry world, so we get rid of it. So kj equals to 20 is the only answer geometrically that seems reasonable. All right, one more question if you're looking towards blended release. This question involves a midpoint again. AB this time is x squared. BC is 49. When B is a midpoint, that means these two segments are equal to each other. So we're going to say our general equation is AB equals BC. That was based on the idea of a midpoint, so definition of midpoint is the reason why our work is valid. And then when we substitute x squared equals 49, gives us an equation that we can solve using a different algebra skill, using square roots. The square root of something squared is just the something, so just x is left over. And the square root of 49 is actually either positive 7 or negative 7, which is sometimes written with a plus or minus symbol in front of it. So the question is, do both of these work in the problem? Even though all we're being asked to do is find the value of x, we still need to make sure whether these answers are valid or not. So if we do 7 squared, that would make this segment 49, so that seems good. So x can equal 7. If we do negative 7 squared, that means we're doing negative 7 times negative 7. That's also positive 49. So that means both answers this time are acceptable. So both positive or negative 7. Again, that's another problem where you're kind of looking back at some algebra skills so that when we look forward to algebra next year, you'll be ready for it. Last but not least, using the figure, what appears to be true? Appears is a tricky thing in geometry. Just because something looks like it might be in the middle, for example, point K, does not mean that we know it's in the middle. So what appears to be true, all that we can really say is that LM is a segment. We know that because it starts and stops at M. It might have a midpoint, but there's no way for us to know. So all that we can say for sure is that if we take LK and we add it up with KM, the two small parts, we know that will equal the whole entire segment. But we can't say for sure that LK is equal to KM unless we are told that K is officially the midpoint of segment LM. Okay, so just be careful you don't assume things are midpoints just because they look like it. All right, that's the end for today. If you made it to the end of this, then if we were blending, you would be eligible. You would follow the instructions, but this was a practice blended day, so thanks for making your way through. We'll see you in class tomorrow to talk about what you have left to do.